So as we've gone through these nuggets, we've deployed a cluster, cluster 1. We moved ESXi 1, 2, and 3 into that cluster. We enabled DRS, Distributed Resource Scheduler. We verified that. And we set up some affinity rules regarding which VMs should run together, which VMs should run apart, and also some VM to host affinity rules as well. Well, what I'd like to do is rearrange our topology just a little bit and create a second cluster. We'll call it cluster. This is cluster 1. Let's go for cluster 2. And then let's move ESXi 2 and 3 into that cluster. And then we'll migrate the 4 Linux-based VMs as well. And so when we create the cluster, we can enable, once again, DRS for that as well. And what we can also do is we can enable high availability on cluster 2 as well. And that way, we're going to leave ESXi 1 in its own cluster with the vCenter server appliance. So that way, we can play around with ESXi 2 and 3 in this new cluster, and we won't be bothering ESXi 1 and the very critical vCenter server appliance, as that VM is running both the platform services controller and the vCenter server application. So to do that, let's go ahead and right-click on the data center. And under Actions, we'll select New Cluster. We'll call it Cluster 2. And let's turn on DRS. And let's go ahead and leave that fully automated. That's great. And we'll say it can go ahead and be aggressive. What we can also do here is enable HA. What I'd like to do is let's hold off on putting a check in that checkbox until we get all the hosts and VMs moved over to this cluster. And then we'll come back and then we'll enable high availability on this new cluster. So for now, just DRS is enabled, and we'll click on OK. So if we expand that cluster, it's absolutely empty, nothing there. So let's go ahead and move ESXi 2 and ESXi 3 over to this cluster. Now in the past, we've just dragged and dropped and it worked great. However, because these ESXi hosts are participating in the cluster called cluster 1, we can't just yank them out of there and hope for the best. What we have to do is place them in maintenance mode, which I'll walk you through how to do. And then once they're in maintenance mode, we can move them over to cluster 2 and then take them out of maintenance mode. So to put them in maintenance mode, we could right-click on each of them and then hover over maintenance mode and specify enter maintenance mode. It's also giving us the option here with this checkbox to take any VMs that are powered on, that are currently running on this host, and move them to other hosts in the cluster. We'll click OK to proceed. And then we can do the same thing for ESXi 3. We'll right-click on ESXi 3, hover over maintenance mode, and then from the submenu select enter maintenance mode. And click OK. So if we had dozens of hosts that we need to put in maintenance mode, we could go to the cluster, and with the cluster selected, we could click on the hosts tab here, and then we could go ahead and highlight ESXi 2, and then with the control key, grab ESXi 3, or if we had a whole range, we could click on the first one, and then hold the shift key down, click on the last one, and then we could use these tools here, or we could right-click and select maintenance mode, and it would confirm that we want to apply it to both of them. And that's a convenient rule of thumb to follow when we need to do the same exact action to multiple objects. So now that they're both in maintenance mode, we can go ahead and move them. So now what we could do is we could drag and drop them from cluster 1 into cluster 2, or we could right-click on cluster 2. We can select from the Actions menu, Move Hosts into Cluster. We would select the hosts we want to move, and with them selected, click OK. And then after a moment, go ahead and click on Refresh. And there they are. Now, also, VM2 came over because VM2 was associated with one of those ESXi hosts. The reason that VMs 1, 3, and 4 didn't come over would be because I assumed they are all associated with ESXi 1. We can click on the cluster, and on the cluster view, we can click on VMs. And sure enough, those 3 VMs were associated with ESXi 1. And if we want to bring those 3 over as well, we can go ahead and click over here for VM1 to select that. Hold down the Shift key, click on VM4 so that all 3 are highlighted. And then we can go ahead and right-click and select Migrate from the menu. It's asking if we want to perform this action on 3 objects. We do, those 3 VMs. And let's go ahead and change the compute resource only. We'll click on Next. And instead of dropping them on specific hosts like ESXi 2 or 3, let's just click on clusters, and then we can specify that we want them to go into cluster 2. It checked out the compatibility for cluster 2 and it said, like all hosts in this cluster 2 are in maintenance mode or having a problem. I don't think it's a good idea. And actually, I don't think it'll let us continue. So let's go ahead and minimize this just for a moment into work in progress, which we'll put them over here on the right. And what we'll do is we can go ahead and let's bring up these ESXi hosts. So we'll right-click on ESXi 2, hover over maintenance mode, and select Exit Maintenance Mode. And then we'll do the same thing for ESXi 3. We'll right-click on it, hover over maintenance mode, and select from the submenu Exit Maintenance Mode. Awesome. So now that we have some resources in this cluster that can support VMs. Let's go ahead back to work in progress up here on the right. We'll click on that to bring that up. We'll click on the 3 virtual machines migrate that we were in the middle of. That'll restore that process for us just where we left it. We'll click on the clusters button once again. We'll select cluster 2. This time, the compatibility check succeeded. Fantastic, because we actually have some resources there. And click on next. One of the beautiful things about a distributed switch that all the hosts are participating in is that the networking for those VMs is going to stay the same on the same distributed switch port group. And we'll click on next. And then we'll click on finish. And there they are. Great. So now let's focus on high availability and enabling it. To do that, it's a property of the cluster. And so with cluster 2 selected, we'll click on configure. And then in this middle pane, let's go up under services. Here we have an option for vSphere DRS. It's currently enabled. And right below it, we have vSphere availability, which is referring to high availability. Now it's currently turned off because we didn't check the box for high availability when we created the cluster. So let's correct that now. With vSphere availability selected, up in the top right here, we'll click on the edit button. So on the left, we have a menu of options. The first option here for vSphere availability is to click the checkbox to turn on the feature. There's also a feature for proactive high availability, and that's if we had an external system. Let's say, for example, we had a system that was monitoring the CPU heat or the fans or other aspects of the physical host that could report into vSphere and into vCenter, indicating there's a problem. And forewarned with that information, vCenter could be proactive in moving VMs off of the hardware that we're currently getting reported on as having an issue. So in our example here, we're just going to use the traditional vSphere HA. And here are the defaults. If we have an ESXi host failure, it'll restart the VMs on another host in the cluster. If we have a host isolation event, that's where the heartbeat over the management network fails, but the data store heartbeat still indicates that the host is alive. We can enable that and then choose our response of what we want to have happen. If we have some issues in getting to the data store with all paths down, which is part of the VMCP, the virtual machine component protection, we can enable it and decide what we want to do. And we also have from VMCP the option of what happens if we have a permanent device loss and what action do we want to take if we were to enable that. And this bottom option is for the VMs themselves. We have a VM, it's running VMware tools. Do we want to monitor that VM? We can enable the feature and restart that VM in the event that the heartbeat stops there as well. So to change these, we simply go down the list. So we'll click on failures and responses. So here we can enable the feature and then subsequently specify what we want to have happen. So for these other options, we have drop downs. We can also expand each one of these and take a closer look at them. So for example, all paths down between the host and the data store. Currently, this part of VMCP is disabled, but if we want to enable it, we could issue events. And then we have a couple of options regarding powering off and restarting VMs conservatively or aggressively. So I'm going to leave that feature disabled. Here's the permanent device loss. It's disabled by default. We could issue events if that happens, or we could power off and restart VMs. So I'm going to leave that disabled as well. And then regarding host isolation, this is when the heartbeats on the management network fail, but the master can still see that the host is periodically updating a file on the data stores. And if we do have host isolation, what do we want to have happen? And then we have two options. One is shut down and restart the VMs, which is a graceful approach. The other one is power off and restart VMs. So I'm going to leave this disabled. And then we have VM monitoring as well. And if we turn that on, it simply means that if the VM running VMware tools no longer responds to heartbeats, just reboot that VM on that same host. And I'm not going to enable that feature either. What I'm after primarily is the host failure, where if we have a host that fails, we're going to simply restart the VMs. Now, this next option, called admission control, can save our bacon. Let's use a scenario with 3 ESXi hosts. So we have ESXi host 1, 2, and 3. So these are each ESXi hosts. And let's also imagine that they are in the same cluster, providing the resources for that cluster. And furthermore, let's imagine that each one of these has memory, and we'll give them 16 gigs each. And then down here, we have some VMs. Now these VMs are running on these hosts, and let's say we have 5 of them. And let's imagine that you and I have been given the requirement from our manager that we want to have high availability and use that in the cluster, and that in the event of a failure, we want to make sure that all of our VMs can still run. Well, if we look at our totals here, if all the hosts are up, we have a total of 48 gigabytes of RAM or memory in the cluster. Now, there will be a little bit of overhead that's taken away based on just ESXi, the hypervisor running, but most of that memory will be available for virtual machines. So we have 48 gigs at the cluster level. And each of these VMs, let's say they've been provisioned for 8 gigs. So if we total that up, we have 5 machines, 8 gigs each, and that'd be 40 gigs that are required to support these 5 virtual machines. So with high availability in the cluster, the goal is if we have a host that crashes, that we can automatically restart the VMs that were on this host on another host in the cluster. So let's imagine that this host, host number 3, goes away. And now as a total resource for the cluster, we have 32 gigs. Well, if we look at the requirements for the VMs, all these virtual machines will not be able to run on the cluster that remains with just 32 gigs of memory. So if these 2 virtual machines, for example, were running on ESXi3, perhaps one of them is able to be restarted, assuming we don't have too much overhead from the hypervisor to squeeze in that last 8 gigs to get into 32. But certainly VM5 or some other VM that needs resources will not be able to run in the cluster. It will not be able to be restarted. And that's where admission control can help us govern that and tell us ahead of time if we have a problem. So with admission control, we do have some options here. One is we can disable the feature and say, you know what, we'll just stuff VMs in this cluster, and if we don't have enough resources to restart everything, we don't care. However, it's very likely we do care. So what we could do, instead of saying disabled, we could say we want to go ahead and do admission control based on slot policy. Now, this is not a Las Vegas slot machine thing. The slot policy, with its default radio button right here, is first of all calculating a slot size. Let's call it a unit that represents what a VM needs. It calculates that slot size based on the maximum CPU/memory reservation and the overhead of all powered on virtual machines. So with a virtual machine, we can reserve it, effectively guarantee it a certain amount of CPU and a certain amount of memory. And it can do that calculation for us based on our heaviest hitter, which would be the VM that has the highest reservation for CPU and memory. Or we can choose this second radio button for a fixed slot size, and we can just hard code the CPU and memory. Now at the moment, we don't have any powered on virtual machines, but let's minimize this for a moment. We'll just tuck it back into the work in progress area. And let's start a VM. So right click on VM1, and from the power menu, let's go ahead and power it on. And we can repeat that process for VM2 and 3 and 4 as well. In fact, let's do that. Let's power on all 4 VMs. All right, so all 4 of those are running. And let's go back to our work in progress and click on the Cluster 2 Edit Cluster Settings to take us back to where we were. And then if we click on Calculate, it's currently showing us that out of our 4 VMs, that's the last number here, 0 of them are requiring multiple slots. And the reality is, out of these 4 virtual machines that are running, we haven't gone in specifically to configure guaranteed reservations of CPU or memory for those virtual machines. So our slot size at the moment is pretty darn small. Or if we wanted to manually configure the slot size with this radio button and specify as part of that slot size, that unit size, the CPU and memory, then we can click on Calculate, and it could tell us, oh, you got 28 VMs in here, and 8 of them are going to require more than just one slot size because they have a reservation for CPU and or memory that's above the slot size that you've configured manually right here. And getting down to the bottom line of why admission control is going to help us is that if we have too many VMs in our cluster where if one host failed, the others wouldn't all be able to run, we want to know about that. We'll get warnings at the cluster level indicating, whoa, you don't have enough resources in this cluster to match your high availability requirements. So a couple other options regarding admission control. We could also specify a cluster percentage. Now, if we use this policy, we don't really need to have a calculation here because it knows it can tolerate one host failure, which is 50%, because I have 2 ESXi hosts that are equal as far as their capacity of CPU and memory. So if we had, for example, 10 hosts and we wanted to tolerate one failure and all those hosts were equal, in that environment, we could say 10% or 1/10, which we need to hold in reserve. So if we ever got above the threshold where there wasn't 10% in reserve, it would give us warnings about our cluster not having enough resources to successfully pull off our high availability plan. And then the last option here is dedicated failover hosts. And for dedicated failover hosts, we simply click on the plus symbol, identify the host for failover, and then if we have a host that fails in the cluster, it can start using that failover host. So for our lab topology, I'm going to specify that admission control is disabled, which means that we can add VMs, and if there's a host failure, those VMs can still be restarted up to the capacity on our remaining host. And then this last option, for heartbeat data stores, we can choose the data stores that we want to use for data store heartbeats. We can also just click the radio button for automatically select data stores accessible from the host, and that'll do it automatically. So if we have lots of data stores and you want to choose two, this bottom radio button could be used. And if we don't select two data stores, we select one, that data store will be selected and an additional one if there's one available. Because it's going to want to use two data stores for data store heartbeats. So I'm going to go ahead and say do it automatically, and then we'll click on OK. And then I'll go ahead and minimize the work in progress. So for vSphere availability for cluster 2, if we have an ESXi host that fails, it's supposed to restart the VMs on the other existing hosts in the cluster. So with cluster 2 selected, let's go ahead and click on summary. Let's see how well DRS did in distributing the hosts on the cluster. Look at that. Did a pretty good job. We're equally balanced, and if we click on VMs for that cluster, here it's showing us that VM1 and VM3 are running on ESXi2. We could also sort based on this column, just click on the header. So VM1 and VM3 are running on ESXi2, and VM4 and VM2 are running on ESXi3. In this nugget, we've walked through the steps for implementing high availability on a cluster. And what we'll do in the next nugget is we'll take a look at the verification and testing by simulating a failover of a host and verifying that the high availability kicks in. And I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.